Have you ever pondered what fire truly is? Fire, a beacon in the night, a tool that has shaped human civilization, and yet it remains an enigma shrouded in mystery. It's easy to think of fire as a substance, a form of matter, or an object. But in reality, it's none of these things. Fire is a chemical reaction, a dance of molecules in a grand ballet of energy and light. It's a process known as combustion. This process is not just about burning or destruction, it's a transformation. It's the raw, untamed force of nature that turns wood into warmth, darkness into light, and raw food into a feast. Yet, despite its familiarity and its crucial role in our lives, fire continues to baffle and bewilder us. Its ethereal flames flicker with questions, many of which are still unanswered. Now you may be thinking, what does combustion mean at a molecular level? To understand fire, we must delve into the realm of molecules. In the unseen world of molecules, a fascinating dance unfolds whenever fire is born. This dance, known as combustion, is a chemical reaction that occurs at a molecular level. Picture this. When you strike a match or ignite a gas stove, molecules of a fuel, be it wood, gas, or even the wax of a candle, come into contact with oxygen in the air. Fuel molecules are eager partners in this dance. They are filled with potential energy waiting to be released. Oxygen, the other crucial partner, is ever present in the atmosphere, ready to react. When these two come together in the right conditions, a spark, heat, or even a mere touch can set off the dance of combustion. As the fuel reacts with oxygen, the chemical bonds in the fuel molecules break apart. This breaking of bonds releases energy in the form of heat and light. Simultaneously, new bonds form, creating different substances as byproducts. Primarily, we get carbon dioxide and water. Yes, water. Surprising, isn't it? The very thing we use to douse fires is also a product of the fiery dance. The heat produced in this reaction is pivotal. It ensures the dance continues, making fire a self-perpetuating phenomenon. As long as there is fuel to consume and oxygen to react with, the fire will keep burning, the molecules will keep dancing. In essence, fire is a hungry entity, always seeking more fuel, more oxygen, so it can continue its intense and captivating performance. This molecular dance, this process of combustion, is fundamental to understanding fire. It reveals why fire is both a giver of warmth and a destroyer, a captivating spectacle and a potential hazard. It's a delicate balance, a dance on the edge, if you will. Closing. But what about the flame? What gives fire its mesmerizing allure? The flame, a beacon of light and warmth, yet another fascinating facet of fire. Our journey into the heart of fire brings us now to the enigma of the flame. A flame, in its simplest definition, is the visible, gaseous part of a fire. It's the part that we can see. But what determines its shape and color? Well, the shape of a flame is primarily determined by the type of fuel being burned and the conditions in which it is burning. In an environment with plenty of oxygen, like the open air, flames tend to be teardrop-shaped. The color, on the other hand, is indicative of the flame's temperature and the nature of the substances being combusted. Now let's delve into the layers of a flame. A flame is not just a single entity. It has different zones, each with its unique characteristics. The outermost layer, or the blue zone, is the hottest part of the flame, reaching temperatures of around 2000 degrees Celsius. It's here that complete combustion occurs, with oxygen reacting with the fuel to produce heat, light, carbon dioxide, and water vapor. The middle layer, or the yellow zone, is not as hot as the outer blue zone. It's the part of the flame where incomplete combustion occurs. The fuel reacts with a limited amount of oxygen, producing not only heat and light but also particles of soot. These soot particles are heated up and start to glow, giving the flame its characteristic yellow color. Lastly, we have the innermost layer, the dark blue or sometimes nearly invisible zone. This is the coolest part of the flame, with temperatures that can be as low as 600 degrees Celsius. Here the fuel is vaporizing and beginning to react with the oxygen, creating a foundation for the reactions in the outer layers. So, we have unraveled some of the mysteries of fire, but have we unearthed all there is to know? Our quest to understand this captivating phenomenon continues. Stay ignited, for the flame of curiosity is far from extinguished. Despite our understanding, fire continues to baffle and astound us. It's true, while we've made significant strides in comprehending the nature of fire, there are still numerous unanswered questions that keep scientists on their toes. One of the major areas of research is understanding the exact nature of fire. When we talk about fire, we often refer to it as a thing, but in reality, it's a process, a chemical reaction. But what about the flame? Is it a gas, plasma, a new state of matter altogether? These are not just philosophical musings, but real questions that scientists are grappling with. Then there's the behavior of fire in different conditions. We know that fire behaves differently in zero gravity, forming a sphere rather than the typical teardrop shape we see on Earth. But why is that? And how does fire behave under extreme pressure or in varying atmospheric compositions? These aren't just interesting questions. They have practical implications for everything from space travel to deep-sea exploration. Fire's potential uses also offer a fertile ground for inquiry. We've been harnessing fire for millennia, but are we using it as efficiently and safely as possible? Could we, for instance, develop new types of fire that burn cleaner or hotter, or that can be controlled more precisely? Scientists are hard at work on these questions, conducting research on everything from cleaner burning fuels to new firefighting technologies. As we delve into these aspects of fire, we're not just increasing our knowledge, we're also potentially unlocking new technologies, improving safety, and even perhaps shedding light on other seemingly unrelated areas of science. So, next time you gaze into a fire, remember you are not just looking at a flame. You are witnessing a complex dance of molecules, a testament to the wonders of science and the mysteries that remain. Fire, it seems, still has plenty to teach us.